So, good afternoon, everybody. Let's start this session about risk assessment. So, I'm Captain Laurent Alfonso. I'm a firefighter working for the French Ministry of Interior as the Directorate General of Civil Security and Crisis Management, in charge of European affairs, and also seconded at the Union for the Mediterranean as Senior Advisor in Civil Protection. So, thank you very much for attending this session, dedicated again to risk assessment. A very warm welcome to the organizer for the invitation and for this fantastic organization, fantastic event that started this morning in a beautiful, fantastic place, location in Porto, in Portugal. So it's a great pleasure, really, a privilege for me. And I will have the pleasure to moderate this session. After words, so I would like first to introduce our exceptional panel for this session, and I will start presenting our guest. Ladies first. So, Kathleen Stoof, she's specialized in pyrogeography, interdisciplinary study of the distribution of wildfires. National delegate of the Netherlands to the EU expert group of forest fires, also coordinator of the innovative training network PyroLife. She will probably say a few more words about this. Our second guest, to my right, is Alan Hager from University of Washington. He begins his forest fire service career in 1987 as a planning analyst. He works on a wide range of forest management issues, in particular wildfire risk and scenario planning, which will be very important in our exchange during this afternoon. Alan is adjunct at several universities, among them Northern Arizona University, University of Portland, Oregon State University, where you serve as an advisor to several PhD students, Alan. So you're also a faculty research associate and Forest Service international scholars. And with your research group, you map wildfire risk transmission to communities and combine this information with other land condition assessment to explore cross-boundary investment scenario as part of shared stewardship efforts. You're also experimenting with forest landscape models to understand the synergies between wildfire and forest management to improve landscape resiliency on fire-excluded western forests. And in prior work, you developed several DSS, decision support system, and I'm particularly interested with this part of your work and how you liaise with map wildfire risk and landscape models to improve resiliencies on fires. Last but not least, you had the opportunity to share your experience and work in Europe, France, Italy, Portugal, Sweden, and Ukraine, but also in Africa, in particular in Kenya. You are currently on detail to the Washington Office Research and Development under the Sustainable Forest Management Research Program area. You will have, just after the presentation, a keynote that will be a patient to listen. Our next panelist is to the left of Kathleen, Carlos da Câmara. Carlos, you are an associate professor at the University of Science of the University of Lisbon, and I had the opportunity to measure how famous you are and well-known in the audience and the public. Congratulations, Carlos. You are also senior researcher at the Dom Luis Instituto. Your research areas include the remote sensing of active fires and bird areas, the retrieval of land surface temperature and emissivity from satellite observations, the short and medium range assessment of meteorological fire risk, the recovery of vegetation after large wildfires, the meteorological conditions associated to extreme events, in particular droughts and heat waves, and finally, the activity of planetary waves in the atmosphere, in particular blazing episodes and its impact on climate variability. And our last guest is Francisco Rollo, Mayor of Oliveira do Hospital. Sir Mayor, welcome. You are a degree in sociology and postgraduated in project management before to become the mayor of your municipality. You have been a deputy mayor of Oliveira, and you are sharing and have chaired several agencies, commissions, among them Integrated Development Agency of Tabua and Oliveira do Hospital and Beira Serra. Sorry for my very bad Portuguese English. Also chair Commission for Protection of Children and Young People, Association for the Integrated Development of Mountain Villages Network, Agency for the Development of Nature Tourism, chairman of the Civil Protection in Oliveira, member of the Sub-Regional Commission for the Integrated Management of Rural Fires in the Coimbra region, and you are contributor in field studies with the Sphere of Interreg, Center for Regional Development Studies, participant to the project Mountain Villages, and as a professional career, you're a technician at the Association of the Integrated Development of Beira Serra. So your experience in the past regarding fires that affected your municipality will be for sure very interesting and contribute a lot in risk assessment. So before to give the floor to Alan, so when we talk about risk assessment framework, what is the purpose? So I have a definition taken from this document, which is a peer review assessment framework for the Union Civil Protection Mechanism, implemented by DG ECHO. It's an instrument of prevention preparedness, and it has been the creator with the CMCC, the Euro-Mediterranean Center for Climate Change in Italy, and Mrs. Casartelli in particular. So what is the purpose of assessment? So I like particularly this definition, which is to provide inputs into the decision-making process and to inform policymakers, major stakeholders, and the public about risks. The assessment helps to monitor and review risks and vulnerabilities and provides a basis for planning disaster risk management and implementing related measures. Of course, the landscape fire governance framework had key points on how to consider the risk assessment. In particular, considering the risk assessment in wildfires, level of governance, risk perception of the socio-economic groups, and predictive analytics and projections under different scenarios. So these introductory words were to launch our, I hope, successful session with our guests, with, I hope, your full commitment and participation. So without wasting more time, I give the floor to Alan for a keynote, and I will come to you just afterwards. Thank you, Alan. The floor is yours. Thank you.
Thank you, Laurent. Okay, so thank you to the conference organizers for inviting me to Porto in Portugal. And today I'm going to talk about future challenges to the application of quantitative risk analysis for wildland fire. And I really had to put blinders on for this study because the field of risk assessment, even in the world of wildfire, is huge, and there's really strong work all around the globe, and more very interesting and very thorough studies and assessments are emerging all the time. And so this is going to be a very US-centric talk. I apologize for that, given the composition of our audience here. And I'm going to talk about sort of a risk journey in our Forest Service, which is a very large decentralized agency that manages 160 of these national forests, more or less, that is increasingly confronted by wildfire problems, especially out west. And again, the talk is going to be a little bit Western-centric to where I come from. Okay, so in the U.S., Mark Finney, who was a scientist at the Missoula Fire Sciences Lab, set the stage for quantitative, wildfire risk analysis, excuse me, with this paper in Forest Ecology and Management in 2005. And yes, there were some, risk concepts before then, but, he laid it out and explained why we would want to use, quantitative risk analysis, and sort of left some crumbs for people like me on how you might go calculate it. But, and he published a formula in there, which is the standard formula for risk that's adopted by the Society of Risk Analysis, and it's, the expected loss is the product of a probability of a fire. In this case, we're talking about fire risk, times the loss or effect at that intensity. And this big summation symbol is because fire can hit a pixel or a piece of ground at a wide range of intensities depending on the weather, and you have to consider all those to come up with some average expected loss. And so, and Mark's formula is, if anybody goes and checks, is a little different than this, but you'll see why I simplified it. But it's a statistical, estimation. We don't know exactly what it is. It has a variance about it, and it has probabilities because we don't know when fire's going to hit. It's some we would like to, but we just don't know. And it's just like your car insurance. Insurance companies don't know when and you're going to get in an accident, if you are, and what the intensity or loss is of that. Okay, so. And the units for risk can be, really anything. And so, I've worked on the expected loss of carbon, the expected loss of biodiversity. Units can be anything, and they can have both space and time dimensions to them. So it could be risk over, the entire U.S., or it could be the risk at a particular pixel. It could be for today, or it could be per year, or it could be anything. So there's a whole myriad of ways of taking this formula and applying it, as you'll see. I got interested in risk in the western U.S., applying it to the problem of endangered species that are threatened by wildfire, and this is, of course, a global problem. And one in particular, this little furry owl creature, the northern spotted owl, was listed as a threatened endangered species in 1990 in the U.S., and it inhabited extensive areas up and down the West Coast, and protection was established under this Northwest Forest Plan on over 24.5 million acres in the Pacific Northwest and part of California. Now, not every acre was protected, but that was the area that covered this revision to how the National Forests managed their lands. And at the time, the Pacific Northwest was what we call a timber breadbasket. We logged and logged and logged big trees and pumped out billions of board feet of lumber every year. That all halted with the listing of this owl. So it was a keystone species in terms of how it affected the management of national forests in the Northwest. Now, there was some consideration of fire in the plan, but not much. And I know that because I was corrected on that by a colleague who said, yes, we did, but it wasn't much. And sure enough, in 2003, this Davis Lake fire in central Oregon burned 5,700 acres of suitable habitat, probably lost a couple owls, and immediately the forest industry, who was shut down from the spotted owl listing, questioned the science behind the forest plan and said, if you let us log, we could protect the habitat. That'd be much smarter than putting all the forests in these conservation reserves. So this is one of these problems of competing risks. There's risks from logging to owls and habitat. There could be short-term negative habitat impacts, long-term benefits versus fire. Who knows? So the Deschutes National Forest, which is about 1.5 million acres in central Oregon, you can see in the lower part there a little inset of Washington, Oregon, and Idaho. They proposed this 5 Buttes project. and it was a compromise. They're going to do some logging, but they're going to do the logging to protect habitat. It was 160,000 acres, and the red area is the Davis Lake fire, just south and east of Davis Lake. And they came to me. I was working in the area at the time and teaching fire modeling, and they said, can you use risk analysis to show how treatments will reduce fire impacts of the owl habitat, including the uncertainty of it? Okay, so can you use risk to do it? And so I devised, to make a long story short, a plan to treat between 10 and 50% of the lands, and I oriented the treatments that are shown in the orange to block fire from entering the owl habitat, shown in green. And I used an algorithm that used azimuth to place the treatments. Now, you can't just treat anywhere. You can only treat where it's available, according to administrative, where it's logistically feasible, and also it needs a treatment. In other words, it had a fire risk in it. So I developed that with varying levels of treatment plans, and then I used Mark Finney's Flam Map model, which in 2005, this was like high technology to be doing this stuff, but I simulated 30,000 wildfires using the Davis fire as the, quote, problem fire, and then I mapped burn probability, which is the probability of a pixel burning given an ignition in this case, and looked at 4 levels of treatments. And you can see TRT0 is not treating its existing condition, and if they treated 50% of the landscape, the burn probability substantially decreases. So, I discussed this with the forest. They thought, well, that looked great. So I combined the burn probability with fire effects, okay? So I'm using the risk formula. Burn probability is the P, and the loss is on the L is the loss, and that's shown on the right. And to do this, I ran every stand in that landscape through a model we have called the Forest Vegetation Simulator, and I forced in fire at different levels. And when the fire hits a certain intensity or flame length, it would eliminate the canopy required for owls, which is 40%. So every stand varied in terms of their flame length, and I matched that threshold flame length with the probability distribution shown on the lower left. Remember, every pixel's got a probability distribution. That's why you have the I subscripts on both the loss and the probability, and came up with a quantitative risk according to the Mark Finney formula. And it's sort of underwhelming, the change in risk that's shown here between the TRT0, that's no treatment, and 20% when you map it. But when you look at the expected loss, calculated according to formula against percent of the landscape treated on the right, you can see a fairly significant drop in risk as you implement treatments, especially up into the 20%, and then you get diminishing returns. And we see this same curve over and over when we do fire simulation studies and look at field treatments, sort of this diminishing return effect. So the forest used that risk analysis in their, what we call the NEPA document, the environmental analysis. It was appealed. Everything the Forest Service tries to do is generally appealed, and we get sued probably once a week. In the US, you can, private citizens or organizations can sue federal agencies over their proposed land management actions, and they, environmental groups and the defenders of wildlife said that, this is just a ruse to get, cut down big trees. And it went all the way to the Ninth Circuit Court, which is in San Francisco, I think, and covers our West Coast. And it's a big deal to get appealed that high, and the judge particularly liked the risk analysis. And he said, our highest deference is owed to the Forest Service technical analysis and judgment in its area of expertise. And in a way, I wish he would have known better, but he liked it. And it was some of the best work that we'd done. And so we won. And they went ahead with the 5 Buttes project. And, the idea that the Forest Service could do sound quantitative risk analysis and defend its proposed actions really was elevated in the agency, mostly because the supervisor on this forest became a senior leader in the agency. So at that time, I really got interested in this high-resolution burn probability modeling with a model then we call RANDIG, which came from Flam Map. And this is the Deschutes National Forest. And you could just, look at these maps and see all these fine-scale patterns of fire behavior. And we could look at, fire connectivity, source sink of sources and sinks of fire. The outputs include ignition points and perimeters and intensity grids. This is probably 300,000 simulated wildfires under some different weather conditions, and just provided a treasure trove of information to understand fire. And we're still all students of fire, and this was a great way to learn the effects of topography and different fuel compositions, et cetera, et cetera. And it wasn't long before we scaled that up, bigger computers, of course, and bigger, larger scale, fuel maps. And we had a burn probability map for the entire U.S. And this was, I think, around 2011 or 2012. And I thought, well, this is really cool. And then over the years, I've collaborated with a number of people over here in the Mediterranean region, and we've done some high-resolution burn probability analysis for Macedonia, Portugal, Catalonia, parts of Sardinia, Tuscany, Liguria, et cetera. And these have all been used in various studies of field treatment effectiveness and risk assessments, and et cetera, et cetera. So, but what turned out to be more of a problem than burn probability was this problem of what is the effect of fire on things. And generally, people use process-based models to try and understand that. And two we have in the US. On the left is a first-order fire effects model. And those graphs show as you force in flame lengths into a stand of increasing flame length, that's how proportion of the stand that dies. So it shows on the lower left graph at about 2.5 meter flame lengths. In this particular study area, you're losing all the trees. So that's the loss function, okay? Increasing flame length on the x-axis, loss on the y, and then on the middle panel is when you treat the stand, it bends the shape of the loss function. You raise the canopy up, there's less torching, crowning, and you get a more resilient stand, okay? Loss function for old growth trees, these were just large trees. On the right is for carbon. We took the risk framework and applied it to carbon to examine the question, do fuel treatments save carbon or not? And some of the early research stated that, yeah, you go in and treat a stand, a fire comes, and the intensity is much less, and you save a lot of carbon. Well, the problem is that, A, you remove a lot of carbon when you do field treatments or forest management, and B, the probability of a fire hitting it is very, very low during the lifespan of the treatment or in general, and so you don't get the benefit till the fire hits. And so when you put a risk framework on the problem of carbon benefits from forest and fuel management, it goes very negative, or at best neutral. So the workaround for larger scale assessments was go to these qualitative response functions where these little bars down here show, response function 1 might be applied to these three things where, yeah, you have some loss, but it drops down, or you don't have loss, and you have less loss at higher level intensities. But basically saying, we don't know exactly, so instead of lines, we're going to create low, moderate, high, and very high response of different resources or values of interest, and excuse me, and apply them that way. And so in this wildfire risk and hazard procedures for the first approximation, we used energy infrastructure, watersheds, rec areas, airsheds, structures, and put them all together. And so we built this composite risk map for 14 values based on burn probability and qualitative response functions. And this is where, I started to wonder what we were doing. And for instance, showing this to managers that had both positive and negative benefits, which I'll get into in a minute. And how could a manager or a policymaker unpack this and make a decision from it? And the answer is they couldn't. And it was a marvelous, assessment from a technological standpoint, brought a lot of people together. But as a product, other than getting something published, was, in my opinion, relatively useless. So then I started, wondering how good is the modeling, how good are the assessments, What are the impacts of a lot of drought and climate change that's showing up around the West? I looked at, for instance, in California, the average annual burn probability from our model was 0.007. That's a 136-year fire rotation. And the 5-year average that we've observed is 0.06, 17. So we're observing fire at 8 times higher than predicted by our risk assessment. That's a pretty significant amount. Then we looked at building exposure. So building exposure is quantified as not risk. Exposure just means that fire encircled something at some given intensity, if you want, but in this case, just any fire encircled something. You're not predicting loss. And so our observed building exposure in the last 28 years was average 10,080 buildings per year, and our simulation model predicted 23,000. So we're way over predicting building exposure. Again, building exposure is just the fire encircles the building. We're not stating what happens to it. So that was another sort of a indication of, potential limitations of some of our work. But then low-risk areas identified in risk assessments are starting to burn. So in Oregon, we had these Labor Day fires in 2020, and the circle there on the left shows 3 of those fires that burned in low and very low risk in the Oregon State risk map. And when I mean low, I think the fire return interval was 1 in 300 years they were predicting in those areas, and yet, they just burned. And this is very troubling, and a guy, Andy McEnvoy, actually wrote a paper about, why is the modeling so bad? And then government agencies started predicting risk to private property, and that's really a bad idea, and I've always, from 10 years ago, said, agencies like the Forest Service are not in the business of predicting that people's houses are going to burn down. Leave it to the insurance companies. They're not only better at it than we are, they have the latest technology, they have more advanced technology than we do, and there's some talks here, people working on, at least one working on loss functions for buildings. But that's their business, and they are the ones that are not only better at it, but government agencies should just stay out of it. So the state of Oregon released their building risk map, and the phone rang off the hook, as we say, and the public said, why are you putting me at high risk? Because now my insurance is going to go up. And the insurance company said that, well, don't worry, because we already know you're at high risk, because our models are better than the states anyway. So there was, another sort of sideboard that was being violated on risks. And then, again, I go back to this idea of benefits. So in the West, we have a fire deficit, and there's a lot of areas where we need fire. So they're putting, if it's a low-intensity fire, they're saying it's a benefit. And the problem with that is that when you combine benefits and losses, it's sort of like saying, well, these 5 acres needed some fire, but 2 houses burned down, but it's okay because we got fire on the landscape. It may be true, but it's not the proper way to sort of describe ecological versus social, values in a risk trade-off. They need to be separated. So I was asked to come back and talk to our senior leaders about fire related to these sorts of problems, and especially interpreting risk maps and how to use them, because they have a job of allocating roughly $300 million a year out into the field for field treatments. And they need something defensible. And I gave them this map, and I said, here's the map, we don't really know. And it was sort of, not really a joke, but it was, things are getting really bad. And they said, well, that's great, but this won't work for us because we're not going to spread the money out like peanut butter, was their analogy they used, on a sandwich. It's got to be targeted in areas at most risk, to the best our science can tell us. So, and moreover, we need to identify these areas, and we need a plan. So I asked them what bugged them the most. Can we focus on one thing in the West, and instead of building 14, metrics into one risk map, what's eating your lunch? And they said, the problem of fires starting on national forests and burning into urban areas. And so much of the West, there are urban areas, housing developments, communities built up against our national forests. Fires start on them. They may burn a mile, 5 miles, 10 miles or more. They hit communities. and start permeating the intermix area of buildings and expose and or burn down homes. So we said, okay, imagine now 54 million of these perimeters. We took every perimeter, we figured out how many houses they affected or buildings they exposed, and we tagged that number back to the ignition point. So we went upstream to where the risk started on the national forests. And we made this map of hotspots of risk transmission. So we're no longer really talking about, or exposure transmission, sorry, technically. And we made this map that shows the sources of exposure to communities. So it's not a risk map estimating loss on the private property, it's where the fires are starting. And they asked, well, okay, well that's fine. Can you prioritize those now for us to treat with our fuels budget? So we took this map, and my postdoc, Cody Evers, the map is good, but it's irregular and difficult to divide up into logical units for planning and treatments. And so Cody took it and put it through a process of image segmentation and created this map that we christened a fireshed map and created this fireshed planning framework. So fireshed terms have been used including in several ways, including me. It's been recycled, but we recycled it once more, and we called these firesheds, and it turned out that about 250,000 acres, 100,000 hectares, was about the right spatial scale to encapsulate wildfire exposure transmission to communities. And we found that 5% of them contained 70% of the exposure. The top 10% contained 85% of the predicted exposure to communities. So here's a problem that the policy people could kind of wrap their head around and say, well, maybe we could treat that and actually fix that particular problem. So from there, we created this fireshed planning framework. So firesheds are in the middle. And then we created project areas nested within that, and then stands. And so the Forest Service, our federal agencies do projects at about 25,000 to 50,000 acres. It's just limitations of logistics and machinery and planning and all other, lots of things come together. That is our unit of change, which is another issue with risk assessments because they're all pixelated, and you have to turn pixels into projects to create a decision product out of a risk assessment. So we created this framework, and then we built a 10-year plan. We asked them, how long do you want to take to treat it? And they said 10 years. And they said, well, how much do you want exposure do you want to treat? And they said 80%. They looked at the map. So we said, fine. So we made a plan using the planning areas. We phased in activities shown on the left to account for the fact, the Forest Service just can't run out there and start, cutting trees tomorrow and reducing fuels. So we had a planning, capacity building, first entry, second entry plan, and then we have this scenario planning model we call FORCES, which we've done a bunch of case studies, and we called a 10-year treatment plan. And this is zooming into California, and those red circles on the left, those are planning areas, and that's the implementation sequence. And this was the first time that someone had actually come to them with an actual plan we have the National Fire Plan, we have cohesive strategy, we have shared stewardship. None of those are plans in the sense that they tell you where to go, what to do, and when over a period of time. So we wrote this up in landscape and urban planning, and we did an uncertainty analysis behind it, which I don't have time to talk about. But this was a giant policy experiment with them. But they turned around and sold this to Congress, and they launched a 10-year strategy. They had to change the name because the 10-year plan wasn't, catchy enough. So they call it Confronting the Wildfire Crisis Strategy. We'll focus on key firesheds, large forested landscapes, with a high likelihood that an ignition could expose homes, communities, and infrastructures to wildfire. And this is a report. You can Google Wildfire Crisis Strategy, and on the right are shown the high priority landscapes in the first round of funding, which was a significant amount. And they didn't exactly take our firesheds. There was some bending of the boundaries to conform to where we're already working. And but the plan and this singular focus on this problem of fire transmission was kept intact to the ground. Now, there was a lot of criticism that, the Forest Service, we manage a lot of different resources. We shouldn't just be focusing on, private, what about giant sequoia? What about, carbon? What about all these other things? And the idea was that, we get the funding and we get it down to these 250,000 acre chunks of ground. We can do a lot of good for a lot of different things because field treatments have indirect effects to, everything. Just because it's blocking fire into the community, there's all sorts of ecological restoration and risk reduction values that can be addressed by putting out strategic treatments in these areas. And in 2023, they added funding under this bipartisan infrastructure bill. So, and the best thing is the Secretary of Agriculture is quoted down on the bottom. It's no longer a matter of if, but when, wildfire is going to threaten these communities, realizing that, risk maps should all be a little bit more red and forget the blue and the yellow. Go red. So implementation is going to be a huge challenge, and I'm really into decision support models. We have one called Forces, and so the guts of it have been used to create a new model, Planscape for the state of California, and then land tender by Vibrant Planet, and the land tender people are here. They have a booth, and I truly believe that these cloud-based online planning tools that are highly interactive, highly automated, are what we need to accelerate local planning, to get through the stakeholder engagement process, get decisions out the door, and get work done on the ground. The bigger challenge, which I neglected to put here, is that under a non-stationary future fire regime that we have now, it's extremely difficult to prove success. And so the Forest Service spends a lot of money on fuels, and fire goes up and up and up, and I could show you graphs like we saw this morning, but the bottom line, the variability is so high that even if we immediately reduced wildfire area burn by 20% and claimed it was some field treatments, there's no way you could prove it because of the interannual variability until at least a decade or so, and we've shown that statistically. The biggest challenge is going to be that the policy people who directed money to this can prove that they made a difference, because just because of climate drivers and fuel drivers, wildfire area burn may, triple. And without the plan, maybe, or with the plan, maybe it only would have doubled. We just don't know. So Vibrant Planet, again, it's a cloud-hosted visualization, planning, and monitoring tool. Spatial optimization of the treatment locations. I could go on about our spatial optimization work for a couple of days here, but I won't. And quantifies avoided costs as well as potential ecological benefit. So these new tools are really exciting to me to simplify planning on these complex landscapes and understand how we can bring diverse groups together to make major changes in fuel loadings and forest structure. So, and I'd like to acknowledge my team. I corrupted a quote here by Pericles, statesman in ancient Greece, that the key is not to predict the future with wildfire risk assessments, but to prepare for it, and I think it's appropriate. And my team over the years, Michelle Day, Cody Evers, Pal Paleologos, Bruno Aparicio, Anna Barros, Fermin Alcacina, Rachel Hauptman, Chris Ringo, Pedro Bellavenuti, and Ken Bunzel all contributed to parts of the talk. So thank you very much. Obrigado.
Thank you. Thank you very much, Alan, for this very complete, comprehensive technical and scientific presentation. So it will be very challenging for me to summarize such presentation. So you put the level of debate and discussion at a very high level, but would like to highlight some maybe key points of your presentation before to give the floor to Carlos. So, presenting quantitative risk analysis for wildland fires. So you really presented the trade, a very comprehensive trade on how to use this kind of model for taking as an example endangered species with a hole, for example. Then to jump to predicting a risk applied to infrastructure, to building housing, and how finally you make the link, the bridge with in a predictive approach, how to identify hotspots and how to plan a framework in a 10-year scenario for fuel treatment, for example, and how you mentioned it, how it's challenging to then implement such analysis and plans with the finality to prepare the different stakeholders to face this possible wildfire. So also this raised me some reflection about prevention measures, structural or non-structural measures, of course, high probability and low impact concept also. And I will finish with last point when you mentioned that predicting risk to private property was not a good idea, that it would be better to leave it to insurance companies. So I think this will be a topic we will discuss later on the Q&A session. So thank you so much, Alan. And now we'll give the floor to Carlos, and of course the audience will be able to ask questions to Alan in connection with his presentation or whatever. So, Carlos, the floor is yours.
Thank you. So, hello everyone. I'm a climatologist, and as a climatologist in most projects, I'm used to occupy an upstream position as a data supplier of regarding either to present climate or future scenarios. As a climatologist, I'm also used to bring bad news to the audience, either because targets are not met or because extremes are becoming more and more frequent. I'm also quite used to be on TV making comments about disasters like floods or intense precipitation or extreme fires. So I have a sad life, and to try to compensate a little bit, I try to look at all these tragic events as a good occasion to try to learn how nature behaves, how the mechanisms interlink, and especially how to try to educate people. Alexandre Quintanilha this morning, he used education a little bit hesitantly. From my point of view as a teacher, I would look at education as the right word in the sense that it means not only more information, but structured information in order that people can really grasp what the problems really are. So, as a leitmotif to the importance of the climate issue, I brought this time series that you can see in the upper left corner. So if you look at the time series, if this was profits of an enterprise, you'll be very happy, especially in the second half of the time series, where profits are becoming more and more apparent. If it was, for instance, increasing prices due to inflation, it would be bad news. Well, what I'm showing here is nothing else but an accumulated daily severity rate for each year from January 1st up to December 31st And we can look at this as a first indicator of meteorological fire danger. And so this means really bad news. This is for Portugal, because the time series is steadily increasing, and I don't think you need a statistical test to be convinced that there is a different behavior of the time series. In the right bottom, you can see 3 maps of Portugal, and they are very simple. So the red patches, they mean that there is a positive trend, and they regard to the percentiles, so the first tercile, the median, and the second tercile of this daily severity rate. And you can look at this and say, okay, the worst percentiles, they are not increasing so much. But this is indeed bad news, because the lowest percentiles, so this means the windows of opportunity of having less days that do not favor large wildfires, have been increasingly steadily since 1980. So I'm not going to present any climate scenarios, because I don't think that there is any need. Just look to the recent past and take your conclusions. Well, Stephen Pine this morning, he stated that fires modifications or transitions did occur before we talked about climate change. But climate change is increasing the severity of the problem, and the role of climatologists is becoming more and more important, not only in trying to define better assessments of the probabilities of having very large fires, but also in identifying areas of the Earth, the so-called hotspots, where these changes are more likely to be more impactant, if you want. When we try to look at the relationship between climate and fire activity, I like to go back to the end of the 90s, when I'm still working with José Pereira, and he came to us, or he came asking if we could help one of his PhD students that was looking at the first database with satellite data of fire ignitions. It was just 1 year, and he said, Carlos, do you find any interesting structure? And I said, well, this is the Köppen climate classification. Ned Dwyer looked at me, he was a young student, he said, what's the Köppen classification? For a forester it means nothing, for a climatologist. So the first studies I made were with that, and I'm becoming more and more convinced that you cannot ignore climate, as you cannot ignore weather. And so anytime you want to make assessments about risk, well, climate is certainly one of the issues, and I think that it's worth being addressed by this audience.
Thank you. Thank you very much, Carlos, for this. This is demonstration. Really clear, and yes, unfortunately, we're not going to the good way. So this maybe will inspire our mayor, dear Francisco, because you are in the front line of what Carlos mentioned, the increasing risk of fires. So the difficulty to measure the impact of climate change in one line, the fires, but the reality on the field in a very comprehensive way affect municipalities at local level, communities, citizens, persons, infrastructure. So what is your view and perspective regarding this?
Okay, good afternoon to you all. I'm very glad to be here, and we have a principle. We need more information. We need serious information, technical information, with more sharing of information. This is a good example. At an international level, we can share information from several points of the world, because we live in the same world. We need more preventive intervention, and we need to predict, and we need less fire risk. At the local municipal level, we need to plan. And now we are planning at a regional level. Municipalities in Portugal need to, and are working together at a regional level. We planning in our region, Coimbra region, in the center of Portugal. We have a territory that goes from the sea to the mountain, to the highest mountain in Portugal, Serra da Estrela, and particularly the municipality of Oliveira do Hospital in 2017 was burned by a severe wildfire, who burned 98% of the forestry in just one night. It was a radical meteorological phenomenon. The fire began outside the municipality in the mountains, in the municipalities of the neighborhood, and in that night there was the Ophelia typhoon, and it burned all the forestry, 98% of the forest surface. 13 persons were killed, were dead. More than 1,000 of enterprises were destroyed. More than 80,000 enterprises were destroyed. Industrial areas were destroyed. That was a severe problem. We need to rebirth from that severe problem. And now, when we plan, and we plan as based on information, technical information, but we need to plan bottom up. I need to say that we need to have people in the territory. We need to have machinery. We need to prevent. And when we are talking about risk assessment, I was telling with my team, my technical team in the forest technical cabinet, we have mainly two risks. In December and in January, we have severe rain, we have floods, we have landslides, and infrastructure very damaged. And we ask for governments for help, public help. And since April, particularly this year, we have a severe dryness. We look at the surroundings, and what we see a dryness. We have the vegetation. We have all the forestry destroyed. Now we have 8 AIGPs into how can I translate it to English? It's forest management, ações integradas de gestão da paisagem. Okay, 8 operations to make a new forest with more areas without forest, with more pastures to do shepherds, with more fruit, trees to have fruit and less eucalyptus and monoculture, less pinus, and we are rebuilding all the operations of plantation, and that's the future. And to do that, we need people, and we need to have models, and we need to have knowledge, specific technical scientific knowledge. That's what we are trying to gather up to rebuild a territory. But now we have a problem, and I need to introduce that. The public authorities made a map of hazard of rural fires, who affects some areas, mainly the high risk in my municipality and other neighborhood municipalities who are very affected. And the risk of that map of hazards is originating a very serious problem. The rules of that map, combined with the law, are, and there are severe rules, are getting some problems to the investors. The map of hazard now, and the application of the law is promoting, as I said, severe rules to do investment. And there is a decreasing of activities. There are a decreasing of investment in forestry and agriculture and rural tourism. There is abandon of these areas, so the risk is leveling up. And in the end, the map of hazard is producing more hazard. In several spheres, from regional level to national level in the parliament, for several times I'm noticing that to the political responsibles, that we need, now they gave us to December of 2024 to get back to the map of hazard and to the law, to remake the law. In a time where climate change is a reality, we need, if we can humanize the landscape, if we can put some people in the rural areas, if there are people doing traditional activities, taking care of the territory, we can prevent fires, and we can prevent the destruction, the massive destruction of some small cities and villages. That's why, and they talked about in the morning, the Ministry of Environment, we are talking about implementing some projects like villages condominiums. It's a way to protect the villages. We have projects like safe villages. Why the villages? Because the villages have persons who have lives, who have traditional activities. And there are some people who came from the Netherlands, people who came from Lisbon, from Oporto, and from Middlesbrough, and came to, for instance, Middlesbrough, and came to the interior north and center of Portugal to live in these areas, to invest and to humanize the landscape. Where there are persons with activities, the territory is protected. I finish for now with this statement.
Thank you. Thank you very much, Mr. Mayor of Oliveira do Hospital, because your testimony was very realistic, because you are, again, in the front line, so you describe perfectly what is the interpretation, the consequences, and the impact of wildfires, but not only in your case, because you mentioned also multi-hazard approach. So, again, definitely you as a mayor, you are the transmission belt of this scientific knowledge to technical appreciation. and then how to transfer and to convert it to protection to the citizen, and how to improve the situation by managing the landscape. Not only risk assessment is important, because in risk assessment we're talking about risk identification, analysis, and evaluation. So this is key, and this is a perfect ramp-up, I presume, for Catherine as a specialist in paleogeography. I think Francisco's speech was very inspiring for you, and you will be able to implement and contribute and give a great added value to this. And maybe some solution.
Yeah, thank you. So what strikes me a lot when you're speaking is about the need. So I'm a scientist, and in science, I think the people who are here are often the people that take a broader look than just what's happening in science. But in a scientific world, there's often still people that look at mostly what's happening within science, whereas what you're sharing right now are major challenges about how to live with fire. Actually, it's on the one hand, it's about how to bring fire back into the landscape, but it's mostly about how to bring people back into the landscape. And your story underscores the need for scientists and practitioners, and for scientists to listen and to develop research questions together. And Laurent, you mentioned Paralife in the beginning of the session. So, and actually we have a workshop tomorrow evening at 6 also about how do we need to train people differently if we want to further integrated fire management. Because education in universities and schools is often in silos, it's often in disciplines. And actually in integrated fire management, we need to have people that are able to, as was also discussed this morning, able to speak the language that everybody understands. You need to be able to use words, you need to be able to listen. You don't need to be an expert in everything, because that's just absolutely impossible. But it's really about knowing what you know, and especially about knowing what you don't know, but then knowing people that might know. So it's about collaborations, it's about working across disciplines, it's also working across geographies and countries, and connecting people. And Peter Moore this morning started about fire often being approached from a single gender. But ultimately fire is a societal challenge, and a natural process and a societal challenge for which we need a large diversity of people involved in a dialogue. So that's in terms of education. On the other hand, what strikes me a lot is data, because the wonderful presentation that we started out with, I'm looking at that. Okay, I'm from the Netherlands. Who of you thinks about fires when you think about the Netherlands? Lisa, come on, please. Yes, thank you. Okay, who of you thinks about water when you think of the Netherlands? Okay, yeah, okay, great. So, spoiler alert, we have fires in the Netherlands. And what I hear a lot in international projects...
in England, but last summer...
Yes, in England as well, but absolutely. So what I still hear a lot in international projects and collaborations is when the north of Europe gets fires in the future. Well, we have fires. They've never been away. They've always been there. It's just that our fires are so small that if you look at the satellite products, FS for instance, FS captures 0.3% of all the fire occurrences in the Netherlands. It captures about half of the area burned, 0.3% of our fires. And so our fires are not big, but your fire doesn't have to be big to have a big impact, especially in a country that's prepared for a lot of things except for wildland fires. I started looking into the Dutch fire history. Actually, this was after my daughter was born 2 years ago. I had something to do in the evenings when I fed her, and then she fell asleep. So I started. I read somewhere that we had fire statistics that started in 1922. Wildfire statistics starting in 1922. If anybody knows of countries elsewhere in the world who also started collecting statistics that early, I'd be very interested. So in these evenings with my daughter asleep next to my side, on my phone actually, I was searching for these fire reports. I've been able to track them down, all 70 of them, except for 3. So we have fire statistics from 1922 to 1994. In 1994, actually, if this were a business, the business would be really bad because we started with a lot of fires, a lot of area burned, and then when you read those fire reports, you see that that there's a lot of discussion about, okay, so fire is the enemy, very clearly, because this was about, the data was collected to protect the wood crop, the forest crop, from fire. There was a lot of propaganda, that was the term that was used, and it had these beautiful drawings of squirrels running away from the fire. So we had statistics, we had prevention, we had specialized forest fire agencies, we had integrated fire management, and this is all lost now in the Netherlands. And so between 1994 and 2017, we had no data at all, so we didn't even know how the business was doing. And then the wonderful quantitative analysis that you were showing, Alan, for what I'm thinking when I see that is like, that is awesome. But what you need for that is you need to, so for the fire behavior modeling, you need to know what your fuels are. You need to have fuel models. We don't have that in Northern Europe. You also need to know, to check with to check the model with reality, you need to know where your fires are. For many countries in Northwest Europe, we don't know that. We don't have the statistics, and if you have the statistics, it's for a really short amount of time and not really for a longer period. So the climate analysis you're talking about, fantastic, but we don't know what the business is doing. And I'm talking about Northwestern Europe, but we have a large delegation, fortunately, from many other countries in the world where there are also data-poor environments. And so my question actually to you, Alan, and maybe also to the audience, is like, how do you do risk assessment in a place where you don't have those data, where you can't do fire behavior modeling, where you don't have these fire records? And maybe in the Netherlands, we don't know what the risk is. There is even a discussion about what is risk and what is the exposure. So that's an underlying question, is like, how can you make all these awesome things that are available in the top fire countries, so to say, where all the research is being developed and all the practice is being developed? How can you make that available? How can we transfer that to places where we think fire doesn't exist, or places where we have most fires in the world, but most of the attention goes to other countries?
Thank you, Claudine. Thank you very much. Now, I propose you, regarding the time frame, that to go to questions coming from the audience. I will try to summarize some of them and address them to each of you. So the first one will be considering the integrated fire management, how to develop risk assessment models at different levels of governance. What are the main issues? Technical, planning-oriented, financial? Maybe for you, Francisco. So, considering the integrated fire management, how to develop risk assessment models at different levels of governance? What do you need as a mayor to get as model to be improved and to be adapted, implemented regarding your responsibilities, role of a decision maker? What are the main issues that you already identified in your speech, but what should be the next steps?
We need to invest. Mainly, to do a good investment, you need technicians, well-prepared people. Well-prepared people connected to scientific institutions. We need to do an integrated planning, not at a local level, a regional level, a communitarian level. In the morning, there was a phrase very brilliant: fire has no boundaries. You need to think about fire management at very intermunicipality level, at a regional level. You need to have well-prepared technicians. You need to have technology. At our community region, and Coimbra region, we are investing. For instance, we have video vigilance from the high hills, from the IS mountains, who sweep all over in a cross methodology, who at a previous level identifies the beginning of a small fire. So you need to have technology, and someone to manage all the signs that the technology give us. And we need to invest money, for instance, in the vegetation management tracks. That's high cost. You need heavy machinery to maintain and protect the main roads and the forest roads. And if you can maintain the forest roads, you can enforce, for instance, the shepherds, the agriculture, and that kind of activities who protect the urban areas, because that urban areas are surrounded by farms who have these old traditional. I'm living in a region where I have this experience. And now there's a trend that all the things that remember rural areas, rural activities, and things from the past, I think that there is an idea that we need to sweep all that and live only by technology and gathering all the population in big cities. I'm against that, publicly against that. We need to put people in the countryside. We need to put people in the villages. We need to put people in the mountains. In Portugal, there are people living and with economic activities in the mountain areas, in the rural areas, in the interior of Portugal. When you decrease the investment, people abandon. And that's an error, a public error, to take money and decrease the investment in these areas. When you don't invest, people abandon. When you abandon, well, what you have? A wild forest, vegetation growing all over, entering the yards of the houses, and when you come back in the Easter or in the summer, maybe you have your house destroyed in the last summer.
Definitely, we have to relearn how to consider forest in our society. So it's a very societal and political choice.
If you have people, teams in every municipality doing their job, a planned actions, you can protect these small villages, small towns, and you can protect the territory. That's our vision, our common vision in the Coimbra region community.
Yeah, time has come to create new interaction between forest and our society, definitely. So I will try a question for you, Carlos. So again, try to summarize the questions coming from the audience. So wildfires can become, in certain circumstances, a secondary objective or priority when the effects exceed the fire itself. We're talking about compound emergencies. How to incorporate complex scenarios in a wildfire risk assessment?
Well, it's a very interesting and very tough question, but I'm very glad that someone asked for it. Well, my colleague here in the panel was talking about the almost complete annihilation of forests in their council, I think, how you would call the Conselho. And this was in October 15th.
No, 17.
October 17th, I think it's 15th.
15 October.
October 15th.
Yes.
October 15th to 2017. 2017. And this was the result of what we technically call a compound event, in the sense that we have several extreme and rare situations that converge in a certain instant of time and in a certain region. In this case, what we had was, first of all, a very intense drought that affected the Iberian Peninsula since the beginning of spring, and it became even more severe during summer. And so this means that when we reached October 15th, for instance, October 15th at the time was completely out of the official fire season.
Yes.
And we had so a very stressed vegetation. Then we had Ophelia. Ophelia was also a very rare event because hurricanes, or even what the remains of hurricanes, they don't reach usually the latitudes of Portugal. And so what we had was very intense winds, southerlies, that were steered by Cyclone Ophelia. This is also quite unusual. So in Portugal, we have a saying that from Spain, neither good wind nor good marriage. From a climatological point of view, it's the wind that counts. But in this case, we had severe winds from the south that are a very, very rare event. Then we also have that most of the landscapes that were affected, they have a south-north orientation. And for instance, Pinhal de Leiria, that burned also completely, if in that day there were easterly, so winds from the east, probably it would just burn a small fraction because the fire would be driven towards the coast. But it was southerly winds. And then there was a third event that was in October 15th, 2017. We had the records of one of the highest number of ignitions for October. And this has to do with a forecast of possible rain on October 16th. It was a Monday. And this means that, but 16 was a Monday. And so because there was this forecast of rain, most rural people decided to make small fires because it was the last chance to burn the remainings and prepare the land. So we had this enormous disaster where we never had such a record of burned area in a single day. So this means from our point of view that we have to rethink the ways to tackle these types of problems. So I've been dealing with extremes for quite a long time. It's a difficult branch of statistics, and dealing with compound events, it's even more difficult. For instance, we have quite recently published an article where this event is analyzed from the point of view of compound extremes. And every time I look at that day, I'm learning more and more things. So this is indeed a very important problem. Just another comment that I think that was a good step forward. My colleague, he said that he was counting on technical and scientific skills and links with scientific institutes. Well, when I came from the US in 1991, I was there for my PhD, and my advisor had a small private company that made business on climate issues. When I came to Portugal, I decided, okay, let's try a business. I knocked at the time for a huge number of public institutes and private companies, and the answer was, well, climate is definitely not a problem that is worth investing. So I'm very glad that more and more people are becoming aware that science can help in these issues.
Thank you very much, Carlos. Time is running, so we have 5 minutes left, so I think I will finish this session with a question to Catherine. As a vertical and horizontal approach is essential, and considering that decision-making or responsibilities may diverge or differ, which levels or bridges do you identify as possible common interests? I mean, in terms of the different stakeholders acting in a risk assessment, but not only. So, how to converge on same common interests? So, how do you think we can bridge and liaise the different interests to these different stakeholders? I mean, between institutions, private sector, for example, and the communities.
Very nice question. It links to what was discussed this morning as well, and what Stephen Pine said, is that fire is not a separate thing. Fire is part of everything. And so I'll link it also again to the Netherlands. It's like, you might know that in the Netherlands there's a lot of stuff that is very challenging at this moment, but one of them is a nitrogen crisis, because our landscape and our society is so concentrated, and we produce so much agricultural products for the rest of Europe and the world that we actually produce too much in order to take properly care of our nature areas. So our atmospheric deposition of nitrogen is way higher than it should be, and the government has relied on technology that is now clear that it's not working to mitigate that atmospheric deposition, or the emissions. That links to fires, because in areas where you have a lot of atmospheric deposition of nitrogen, you have a lot of Molinia grass growing. And everybody working in Northwest Europe, and actually everybody working with fire, you know that grass burns like mad. Our fire season is in the spring, when our vegetation is still very dry from winter and the sap stream hasn't started yet. So if we manage to curb nitrogen emissions, then it will be much easier for land managers to stop the proliferation of this Molinia grass growing. And actually, I mean, we have some degraded peat bogs, and also in our heathlands, there are a lot of places where we have very much of that grass, and land managers would like to remove that. So that is one area where fire and land management intersect. Ultimately, I mean, in terms of social activities, I mean, we know that the FireWise program, and there's actually been implementation of the FireWise program in the United Kingdom as well. We see that any community initiatives and it can be about anything, but if you introduce community initiatives, then the benefit can not only be that people manage their home ignition zone, but then the benefit is often also that the community resilience increases, there is less loneliness, people are more supportive, and that helps communities thrive as well. So I think there's quite a range of areas. If you consider that fire is part of the landscape and part of society, and also in the countries where people don't think that they have fires, it's like, for us, it's not realistic to say we need to do something specifically for fire alone. It's especially looking for these synergies, to look for places where we can integrate fire into processes that are already going on, because right now we haven't been able to. There are actually a lot of developments now politically in the Netherlands, and there might be specific actions taken on wildfire preparedness. But in the grand scheme of things, we have to integrate it in things that are going on.
Thank you very much, Kathleen. The next step will be, of course, preparedness, as you mentioned. So I think we're just on time. It's the moment to close this fantastic session. So Alan, Francisco, the mayor of Oliveira, the hospital, the Carlos, and the Kathleen, it was for me an absolute pleasure and an honor to facilitate and to moderate this session. I hope it has been useful, fruitful, and informative for every one of you. So thank you very much, and give the floor to the organizer. Thank you, and an applause for our great guests and experts. Thank you very much.